Okay, in this section of the logarithms tutorial, you'll learn a little bit about how to use logarithms to solve math problems with pH. And in front of that, I'll tell you a little bit about what is pH, what's it mean, what's it used for, how's it used in chemistry, engineering, and mathematics. I'm assuming you have some familiarity with chemistry, molarity, a little bit about the chemistry of water, and you understand what hydrogen ions are. So pH is a measure of acidity in a fluid, in an aqueous fluid. That's a fluid that's water soluble. pH is a number. It's between 0 and 14 inclusive. You will occasionally see values below 0 and above 14, but that's kind of rare. In these four examples, if pH is 1, it means that the molar concentration of hydronium in an aqueous fluid is equal to 1 times 10 to the minus 1 moles per liter. Notice the negative 1 on the exponent corresponds to a pH of 1. If the pH of an aqueous fluid is equal to 7, and by the way, this is acid neutral, it means there are 1 times 10 to the minus 7 moles of hydronium per liter in some aqueous solution. If pH is equal to 0, this indicates that the molar concentration of hydronium in an aqueous solution is 1 times 10 to the 0 moles per liter. So again, the pH value is the exponent on the molar concentration of hydronium. And if pH is 14, which is the largest normally accepted value for pH, it indicates that the molar concentration of hydronium is 1 times 10 to the minus 14 moles per liter. So 1 times 10 to the minus 14 is a decimal point, 13 zeros, and a 1. That's 1 times 10 to the minus 14. So what I hope you can see from this is that the molar concentration of hydronium in an aqueous fluid can vary significantly from a low of 10 to the minus 14 moles per liter to a high of 1 mole per liter. And that's why logarithms are used with pH. It's simply a shorthand method of representing numbers that vary significantly. They vary by orders of magnitude. And if you've been progressing through this tutorial kind of in the order that it's presented, you've seen other instances of numbers that measure something that varies significantly, as in the Richter scale, the decibel scale, or the half-life of different materials. These are all instances where logarithms are used because it's a convenient way of representing numbers that vary significantly, that vary by orders of magnitude. So that's a quick intro to what is pH, and hopefully you have found this begs the question of what is hydronium, and that's the next part of this introduction.